Hey guys, you may recall I picked up an RCA 721. Hey guys, here are the insides of an RCA 721 TS I picked up recently. I actually now have 3 of them because a Video Karma member who happens to live close to me is moving and wanted to lighten the load a little bit, and he generously gave me a 721 and a 630 TS, and I bought a picture tube from him. So I figured it's about time I actually tried working on one of these. Now this is the one I got on Craigslist recently. I've been sitting on there for a while. It's a little bit rough, and the seller kept lowering the price, and finally it got cheap enough that I just couldn't refuse. Now, he had tried powering it up, so I really didn't have much hesitation to try it myself, and much to my surprise, it actually sort of works. In particular, the tuner and the sound worked. I was actually able to tune in a local low power over the air channel 6. The sound quality actually wasn't half bad, but no signs of life on the picture tube whatsoever. So I just brought this up inside, and I thought I'd take a quick stab at getting it to work, kind of the old-fashioned way, rather than my usual shotgun replace the caps approach, since I already know that it seems to be safe to power it up, and it's kind of working. Why not? Also, as I'll show you in a moment, it appears to be 100% original. So what I'm thinking is get this one to work, take lots of reference photos, and then use this as a model to get the other 2 to work. Here's a picture tube, which I believe is also the original. Nothing there. That might be an RCA label on here somewhere. Well, certainly we can see on the base it's an RCA. Can't really say for sure. All I can say is that in some sets that have had replacement picture tubes, I saw the RCA service tags, and there was a note that the picture tube had been replaced. And I did test that in the previous installment. If you haven't seen it, I suggest you go back and watch it. So let's take a closer look at the chassis. It is filthy, to put it mildly. You also see now that one of the controls is bent. I don't think I did that. Likely from getting kicked around over the years. I believe the seller had said it belonged to his wife's father. Somebody did a lovely job of splicing in a new power connector at some point. Much older style than would have come originally with the set. No doubt the original deteriorated and had been replaced. Alright, so it's filthy. It's got plenty of cadmium corrosion, which I will clean off. If it's anything like the 630 TS I did a while ago, it should clean up very nicely. Because actually filth can be a good thing, so it actually protects it from getting corroded, and I don't see any signs of corrosion whatsoever. So, kind of a quick overview to lay the land here. Tuner, speaker, power supply stuff, filter caps, high voltage stuff in here, yoke, some more filter caps. I believe these are for the centering controls, and this power transformer, main rectifier tube, and inside of this metal box here are some big bleeder resistors. They use a brute force approach to generating the various voltages as sets need. There's a fairly hefty secondary that can supply a lot of current, and just sink a lot of that power through some power resistors with taps, and those supply various voltages needed in the sets. Other approaches I've seen are they actually have 2 secondary wirings and 2 rectifier tubes to provide sort of a higher B plus and a lower B plus, rather than just waste a whole lot of heat in here. Quite often, well, not only do this get a lot of hot and waste a lot of power, but they can burn open. There's a common problem with these, but the fact that we got some sound and some life out of this, and I looked at the schematic, and it seems to me the only way that that can possibly happen is that those power resistors are still okay. Alright, now let's take a look underneath. Here's some more of that lovely corrosion. I'll have to wash my hands thoroughly after touching this chassis. It's the dust that's really the problematic thing. You don't want to ingest it or inhale it. The easiest way to tackle it first, take a damp cloth just to wipe that down so you don't get it airborne. I'll show you in a moment. You can clean it off very easily and get a very nice metal surface. Not so easy to do on the underside though, because you got all these parts in the way, but certainly on the outer surfaces. Even the controls are corroded. No, I'm working on this set. Natural inclination is to put this side resting on the ground because it's heavier, but there's kind of some stuff sticking out, like this antenna cables. So I could take these two sheet metal screws out and kind of get this out of the way. But for now, cleaning against the high voltage cage is very stable. Let's see, I got a lot of that stuff on my hands. Not good. Alright, so as I was saying, this looks to be original. I mean, if there are any repairs, it's very, very minimal. So, what I propose to do is be restuffing these for sure. They're original, but they all match. They look like they're all Aerovox, New Bedford, Massachusetts. So I think, oh well, except maybe that one guy there. Which is, it says universal. I guess that says universal replacement, and it's also splitting open. So maybe that wasn't such a good replacement after all. Oh, and a few mic molds, but mostly might be a replacement too. It's pretty darn unusual to find a set that hasn't had anything done to it. But minimal. I can dig up, I'm pretty sure, some Aerovox I've salvaged from other sets to replace those. But as I was saying before, I want to dive in. Before I just dive in and start replacing things wholesale, let's see if we can do a little bit of troubleshooting to figure out why it's not working. So, no high voltage. Well, a few possibilities. Could be a better flyback, but I've had very, very good luck with flybacks. In fact, I don't think I've ever found a bad one. Could be a bad tube. That's certainly a good possibility. Like horizontal output tube could be bad, for sure. Take a look at that. Or the horizontal oscillator isn't running, which is actually the most common problem. Oh, and the picture tube could be bad, but I did test it, and it seems to be alright. Or the high voltage rectifier tube could be bad, but that's fairly unusual as well. So my money would be on the horizontal oscillator not running. And why would that not be running? Again, could be a bad tube, but very likely it's one of these paper caps is leaky. Some circuits, because, well, I should say that I've tested plenty of paper caps in my old videos. I have never, ever found a good one. Meaning that they're leaky. However, some circuits are far more susceptible to being to leakiness. For example, if it's just a bypass capacitor on a DC line just to filter out noise, yeah, it could be leaking. The circuit would still work fine. But if it's like used in an RC time constant for an oscillator, a leaky cap, most definitely a big problem. It can throw the frequency off enough that things aren't resonating right, or it's not oscillating at all. So, well, what I can do to check that out is get this up on the workbench and fire up my vintage RCA scope and see if there's actually any signal on the oscillator. But before that, I want to clean this up a little bit. Okay, first pass with a damp paper towel. Certainly gets a bunch off. Next pass, I'm going to use some spray 9. Strong cleaner. And that gets more off, but if you really want to get it nice and looking, take some navel jelly and dilute it. Like maybe 2 parts water, 1 part navel jelly. I'm just going to do it quick here, put some on a Q-tip and put it on a paper towel. It's already damp. And let that go to work a little bit. So navel jelly has phosphoric acid in it. I believe that is what really kills that oxidation. And I believe it's both oxidation and sulfide. So it's cadmium oxide and cadmium sulfide. And what I like to do is after the navel jelly go back with some like spray 9, which is a base, which will neutralize the acid and also clean off any residue. So if I do that over the whole thing, get back to a nice dull gray metallic color rather, and all my greenish crud is gone. Here we are after a few minutes of effort. Only thing left is fingerprints, which I think is a nice touch. Could be left from when this was originally assembled, or maybe in the plating process. Fingerprints got on there. If I use something more aggressive like metal polish, I imagine I can get them out, but I'm just going to leave it on there. And for these areas, I'll take these screws out and clean that up. Here it is up on the workbench after a little bit of cleaning. Before I dive right into using a scope, I thought I'd try some other more basic techniques first. Not everybody's got a scope. Certainly back then, most service technicians did not. The first thing I want to do is see if I can get it working like it was out in the garage. So I took this chassis out of the cabinet, carried it up inside, cleaned it, bumped into tubes and whatnot. So let's just see if we can get it back to working where we've got reception and sound. Now another issue is what used to be here. When there's early RCA sets, the CRT is actually held in place by the cabinet. So when you pull the chassis out, well, the CRT will just come crashing. You got to remove it first. And then you can't have it up on the workbench unless you build your own little support system for it. Or you get yourself one of these 5AXP4 test CRT made just for this purpose. Well, 5-inch CRT with the same characteristics as a 10BP4, 12LP4, pretty much any early black and white TV set. They all have the same basing, and these are made to be a bit tougher. They can handle upwards of I think 18,000 plus volts. So anything from a 7DP4 to a 19AP4. In other words, a 7-inch to a 19-inch CRT can all be subbed by one of these, and the early rectangulars as well. So you just pop that on here and plug in the base, and that takes care of that. So what do I want to check first? Well, assuming we get this thing powered up and it's still got reception, visual inspection. Already taken a peek under the chassis. Things look to be okay, and I did compare this to photos of some other chassis, and for sure those plastic caps I pointed out are replacements. Originally they would have all been Aerovox paper caps or a few mica molds. So what I want to look at is what's inside here. Couldn't do it when I had it out in the garage because I couldn't get at that screw. Well, now I can. These are the bleeder resistors. I want to make sure they're all intact and have continuity, and then take a look what's inside here. Okay, I got the set plugged into my PR57 so I can see how much current it's drawing. And here we go. Set's on. About 1.5 amps. Did my overhead wiping a little bit.
There's not a problem there.
Alright.
Because I can do it in the mix. And if your man gets in trouble, just to move out on the double and you don't let it trouble your brain. Because away goes trouble.
Alright. Oh, and we got a little raster for a second there. How about that? Not a raster, but a line, I should say. So I'm pretty to have it on long enough. So, you can see the horizontal output tube inside the cage there. It's not blue or anything. So this may be closer to working than I realize. It might just be biasing on the CRT is off. So like the brightness voltage isn't high enough. Just a little blip that time. Interesting. Well, that might have troubleshooting a little bit differently because it looks like we do actually have high voltage. Well, maybe a bit weak, so next I'll get a high voltage probe and actually check how much high voltage there is. And if it is in the ballpark of 7,000 to 9,000 volts, then I'm going to check the voltage in the CRT base, and I can use a new gizmo I just got, which is a test socket for one of these guys. So you put this between the CRT and the plug, and you can check voltages here. Okay, got the set powered up. Got my high voltage probe. Let's see what we get. Yeah, 6,000 on the weak side, but should be good enough to produce a raster. So, next up, I will pop this guy on. Okay, I looked through the service info. I don't see a voltage chart in here. I imagine the Sam's does, but they show a few voltages on the schematic here. So pin 10 we should have 330, then be G2, and G1 is plus 70, and the cathode depends on the brightness from between ground and 225. The curious thing here is the filament, they got a plus 150. I think it's the way they have this whole thing biased. Normally the cathode would be around groundish, and you'd have negative voltage on the grid. But this whole set's a bit odd where they have negative and positive voltages, so they've kind of shifted everything up a bit from ground. Alright, so let's see, let's start on pin 2 and look for plus 70. Or let's just see what we got right here. I'm not even sure what pin I'm on here. Let's see. So it's pin 2, which is, oh yeah, pin 2, and they show plus 70. Varying the brightness control right now. Changes a little, but not much. Varying the contrast now. Not too much. So that's low. Let's see, let's wrap around to should be 10. We got 161. And it should be 330. So looks like I'm gonna guess all the voltages in this set are low. That's pin 11, which then we show between ground and 225. Which should vary with brightness, and it is not. Oh, it's okay, brightness is the inner control. I was doing the outer, I was doing contrast. Okay, brightness, yes. It does vary. When we get up to 203, and they say 225 max, so I'm not too far off there, and I think I'm running this a bit lean, and I'm only running the set at 120, 115 or so. Just cranked up the variac a little. So anyway, we're not off too far from 225. Now that 330 volt that's so low, that is actually derived from a flyback. It's like a boost voltage. So if that's way low, could very well be this filter cap is leaky and pulling it down, because that's a fairly high impedance voltage source. I was curious to see if this voltage climbs at all. So I'm very suspicious of some of these caps not being leaky. I'm trying to current down. This box isn't getting all that warm either, and I still haven't checked for continuity in there. Now, because this chassis isn't a ground potential, these caps all have cardboard covers on them, so I can't really feel them directly to see if they're getting warm. Doesn't feel like it's on. We definitely have some voltages that are off. For sure, having that G2 be so low. Let's check that again. That's going to be a problem. It should be 330, so we're about half of where we should be. Check off the rest of the voltages for the heck of it. Filament. Let's say 150, 115. That's not off too far. So I think the main culprit is that boost voltage. So I could be dragging it down. Well, like I said, my instinct tells me it's that cap right there. Another possibility could be a R142 may have drifted way up in value. Another possibility is the flyback doesn't have enough energy going through it, but say it should be 8500 in the high voltage. We got around 6. It's low, but it's not half of what it should be, whereas this is. So, how do I check my suspicion? Well, track down C127B and clip it out and put a 10 microfarad in its place. Or, more traditionally, quick and dirty way to do it is to clip one in parallel with it. But that only helps when this has gone open and it's less capacitance than it should. If it's leaky, putting a cap in parallel, it's still going to be leaky. It's still going to drag it down. Before I go digging around for that capacitor and resistor, I thought a little bit more about those voltages, and it seemed to me they're not off all that much. CRTs can operate over a pretty wide range of voltage. And got me thinking that there's another issue I've encountered a few times that I keep forgetting about, which is that the focus coil on these test CRTs can push the electron beam off enough that you won't get an image, because these are auto-focusing. They don't need a focus coil. In fact, the focus coil messes them up. Luckily, with a set like this, take off, thumb screw, slide it off the neck, and you can just set it out of the way. Got to leave it still in the circuit because it's part of the power supply, but you can easily get it out of the way. So let's give this another try without that attached. There you go. So when I tried this with the full-size CRT, did I not get anything? Could just have been the ion trap wasn't adjusted right. Yeah, unless we're actually getting an image. I would be quite surprised if I could actually lock to things well enough to get a stable image. But hey, stranger things have happened. Looks like it's locking vertically but not horizontally. Yeah, I think the free running horizontal frequency is just way too far off for this thing to lock. Looks like I'm at a multiple, like 10 times, which should be. So now we're definitely getting into what I was talking about earlier with the RC time constant being too far off. There's a vertical centering, that's working. There's height, I think. Horizontal centering, it's working. I'm not sure what this guy is. Might be drive control. Here's down where I was adjusting things on the back. There are some potentiometers for height, linearity, vertical, horizontal centering. The horizontal controls are all recessed. We've got lock and drive and frequency from top to bottom. So the frequency is the one I think that's really far off, so I'm going to try adjusting that. Let's see if there's actually enough range on this thing that I can get it to lock in. Doesn't seem to be doing a whole lot. Try the lock control. I think things are just too far out of whack. It's just not going to be able to lock. Alright, so let's see. Horizontal oscillator actually determines free running frequency. Oh, it looks like it's using a coil. So, paper cap being off, I don't think would mess things up enough. But there is one on the horizontal hold control. What's also interesting is a 30K temperature compensated resistor. Gotta be careful with stuff like that. You don't just want to arbitrarily go replacing a resistor like that. There's definitely some paper caps in here. Could have drifted off, or some of these resistors for that matter. There's a coil here, L121. It kind of look like it's adjustable. I didn't see a slug for that anywhere. Horizontal frequency is a variable trimmer cap. This is the locking range. Horizontal hold is potentiometer. Okay, so no matter how I adjusted the front and rear panel controls, we couldn't get a horizontal lock, not even close. So I flipped the chassis on its side so we can get at things underneath. Now here is that coil, horizontal oscillator coil. And I'm believe this is that key mica cap coming off of it. 180. Now, I don't mention this adjustment anywhere, but I'm pretty darn sure if you alter that, it's going to alter the frequency. So, I'm going to try tweaking that while the set's running. I still think it's way off because these components are drifted off value, or leaky capacitors, or even a bad tube, but I'm just curious to see if I get this to work without having to actually change any components. So here's the coil I'm going to be adjusting. It's an alignment tool with a slot in the end, like so. While I watch the screen to see if I can get that to stabilize. Right now, that's about the best I can get. Okay. Figured if I put the slug in the coil more, it should increase the inductance and decrease the frequency. Definitely having an effect. Oh, I think we're getting closer. So those lines get fatter and fatter. It's a good sign that getting closer in frequency. Don't have a whole lot left to travel on this slug though. One inch more and then it's going to bottom out. And that's about it. Go back and try adjusting the other trimmers. So here's the frequency trimmer. Oh, so close, close. Try adjusting the lock range. Oh, hey, look at that. Got like everything at the extreme limits of its operation. Oh, pretty nice sharp picture too. So back to why did I not get an image with full-size CRT? Well, not only is little test CRTs pretty robust, but I think they're also can operate over a wider range maybe than the real deal. Or it might have just been an ion trap magnet was misadjusted. Well, the great thing about being at this stage is that I can start replacing components one by one and see if things improve. But I gotta say, I'm very surprised this works as well as it does. This is a TV from 1947. I don't get much older than that. And yes, it's had some repairs, but very, very minor. It does still have some RCA Victor tubes in it, but not many. So it's definitely been serviced over the years. And from what I saw, the voltages are way off. Yet it's working surprisingly well. Now that I can get at things a bit more better here, I'm going to check some of the major voltages and see how far off they really are. In particular, I want to check all of these. I removed the screws from this little box here. Now we can finally see what's inside. Some big power resistor here, which is actually 2 independent power resistors. And then 1 can dome here with 3 sections. What that translates to is our 153A and 153B are the 2 big sections here and here. And on the bottom is the 3 section, 8200, 35, and 100, and they actually are all pretty close to what they're supposed to be. Now that I've identified them, I can just go through and check the voltages. Got the set powered up, so this point's ground. That's right in the middle of this guy right here. So on this side we should have plus 150. So put my voltmeter right here. And dirty connection there. Not sure I'm looking right. There we go. So low, as we've been seeing all over this set. Low. And let's see. And that goes right over to one side of this guy, and on the other side should be 225 and 210. So this isn't too far off, but this is a bit more, so could again be a leaky electrolytic here pulling things down. Now let's go on the negative side. So let's go to the very negative most, which should be over here. So negative 80. Not bad, not bad. Should be about negative 17 on the other side. So that's pretty darn good. Point should be a negative 3.5. So the main thing that seems to be bad is this point right here. It should be 150. I got about 118. Now I'm back to looking at that boost voltage. I got my voltmeter right on the height control. I have the height maxed out, and it's just barely enough height. So I'm right here. And that's also going to the pitch shift. It should be 330. Only got about 260. I've tried adjusting the horizontal drive control, which kind of controls how much power you've got, or how strong a signal you've got going to the horizontal output tube, which in turn controls how much power you've got going through the flyback circuit, and it's really not having much of an effect. So I want to check out this 56K and try if the 56K is alright. 2 other possibilities. This capacitor could be leaky, or that electrolytic. My money's on the electrolytic. So check that resistor, and then if that's okay, I'm going to try clipping out this cap and tacking in a replacement. I eventually track the resistor down, 56K right down in there, and here's the 0.035 thousand volt cap coming off of it. And here's what I get when I check it, about 40K. But let's check the other way. Checking resistors in circuit can be problematic, especially if there still might be a little charge left in the set. It's got 40K one way and 80K climbing the other way. So I think there's still some residual charge left in this set. So I'm going to really test that accurately is to clip one end out. And historically, quick way to do it is you simply snip the lead, and if it checks okay, you tack solder the leads back together. So that's what I'm going to do. Otherwise, you have to heat up a joint and unsolder and unwrap a lead. Okay, I think I'll try clipping it right there. Pull it out a little. Now we can, for sure, test it because we've got it isolated. And 62.8, a little high, but certainly within tolerance. So that's not the source of the trouble. I'll tack that back into place. So bend it back so the leads are more or less touching, and put a little solder blob on there. Not exactly the most secure sound electrical way to do it, but I've certainly seen sets where that's how they were done. So, could be this cap is leaky, or I'm going to trace out the wiring and figure out where the heck is that filter cap, which should be on the other side somewhere. So, red wire's coming down here. So here's all the caps. So it's one of these guys. I think there's a diagram in the service info that'll help me figure out which one of these sections it is. I eventually traced that cap down to this guy, disconnected the wire going to it, tacked in a temporary new 450 volt 10 microfarad cap, and remember, the ground does not go to chassis. It needs to go to the negative lug of that cap, which is isolated from chassis. So, see if it makes any difference. Seems to be. Yep, certainly a lot more height now, that's for sure. And in a bit I'll pull out my cap tester just so we can see what it measures. I'm decreasing the height now, so if I max it out it goes off the top of the screen, so plenty of height. But now I can't get a horizontal lock anymore. So that's pretty typical. As you start replacing parts, you fix one problem and another creeps in. But I already knew I had problems with the horizontal anyways. So still not quite up to 325. Or 330 rather, but 286 is better than it was. Alright, let's see what my solar capacitance tester has to say. It should be 10 microfarad, go up to 450 volts. First I'll check for leakage. Well, that's a good sign. And it's holding charge. But the highest range, still showing leakage. And these numbers are not quite right. They don't really correspond to voltages. If I look at my voltmeter, actually there's 375 volts on that cap right now, not 500. It just can't get there. No lower range, no leakage, but it's only 324 volts. So definitely not good for up to 450, that's for sure. And as measuring the capacitance, yeah, it's actually measuring around 13 microfarads, so the capacitance is alright. And for the heck of it, I've already gone ahead and disconnected wires from the other section, which should be 80 microfarad, good for 450 volts, and that's right on the main B plus supply on the other side of the filter choke. So that's pretty important to the operation, the whole set. So that is C127A right there. So field coil, and that's on the other side of it. So it should be 265, and that feeds all kinds of stuff in the set. So you definitely want that cap to be good. Let's see, capacitance wise, it's kind of right. It's off the scale really on this, as long as it's at 70, and it's kind of an eye-opening near the top of that range. One section of the multi-section cap is leaky. Pretty good chance the other side's leaky too. And here we're pretty leaky. We're not even getting up to 100 volts, but it is eventually forming up. See, the voltage is slowly climbing. So this has a lot of forming up to do, if it can even get reformed all the way up to be able to handle 450 volts, because we're still quite leaky and it's only around 165. And this is what I expected. The caps are either going to be leaky, possibly they can be reformed, or they're going to be dried out and they're going to show as open. Worst case scenario, they'd be shorted out, but the set wouldn't be working if any of these were shorted out. Here it is after about 2 hours, and still 374, still leaky, so I just don't think these are going to form up. The voltage just is not climbing any. I had to just drop a volt. You can't always reform caps. I mean, they do have a limited life. Whether they're used or not, the chemical in the electrolyte starts breaking down over time. The higher the temperature, the faster it breaks down, but they do break down, and they dry out. So that's that. So I will plan on replacing that cap. But I want to do as little as possible to this set and get it working fairly well. As I said, I want to use this as a model to restore the other two. So I'm going to button that back up and actually leave that cap in and shift my focus over to the horizontal circuit. Still haven't taken a look inside the high voltage cage, and I still haven't tested the tubes. So I think that would be my next step. I removed a few sheet metal screws and popped off the cover. You can see what the protected area of the chassis looks like. A nice uncorroded cadmium plated chassis. And then how filthy it is inside the high voltage area, which is typical because the high voltage static electricity attracts dust. Very, very similar, actually probably identical to the insides of an RCA 630TS, which I did some videos on. The only thing that's a little bit different about these RCA sets is that in addition to the horizontal output tube and the damper tube and the high voltage rectifier, the horizontal oscillator tube is actually inside here as well, and that's one that I really want to check. I'll check the others as well, but I figure the rectifier's got to have some life left, or we wouldn't get any high voltage. Likewise, the damper, there'd be some really funky horizontal linearity issues. But no, high voltage is a little bit weak, so it could be a high voltage output tube that's a little weak. And there's another really, really common problem with output circuits. Looking back at the schematic, and that is this resistor right here. It has quite often drift quite high in value. It's a power resistor, and all the power that goes through the tube has to go through that resistor. And I've seen them where they're like double the value, which has got to choke off some of the power going through it, which will reduce the high voltage output. Every tube inside the horizontal cage tested just fine, so I started expanding my testing to the rest of the set. And everything was testing really good until I got to this. One of the 6AL5s has a short. Intermittent, but that tube has definitely got to go. I finished testing all the tubes and found two weak 6AG5s and replaced them with these two guys. Here's a new 6AL5 and 6AT6. The tested kind of weak got replaced. and I button things back up, including reattaching that original electrolytic, even though it's leaky. So, turning it back on. Will any of that make much of a difference? Probably not a huge difference. And if it's still working okay, that's going to be it for now, and I'm going to use this as a reference for the other two. And there's still sound. And getting a raster. Sorts. Play around with the controls and see if I can get the two sync. I rigged up my antenna a little bit better. What I've done is just clip on a couple test leads that are about 3 feet long and just using them as a really quick makeshift dipole in my workshop. Now I'm hoping that will give me enough signal that I can push these circuits to lock on again. So yeah, got horizontal right at the very end of that controls range. Vertical, a little touchy, but it'll lock. Cut down the brightness a little. So it's certainly not the best. There's a lot of twisting in there, but hey, all things considered, it's pretty darn impressive for running on all original parts. Sounds really good too. So I'm just going to put this set aside, literally put it on the end of my workbench on its side, and refer to it while I restore the other two. Not just yet, I got a few other projects I want to work on first, but we'll get to the other two 721 TS's very soon. And as for this set, once the other two are working, I will do more work on this, because although it's working okay, it could certainly stand some improvements, and I don't trust these old caps. I mean, I already know that there's excess leakage, which means those caps are going to be getting warm, and eventually they will fail. And so I already lost horizontal hold. It's just hard to feel the caps getting warm because they got cardboard covers on them. Actually, I can kind of feel this one is getting warm even through the cardboard, and that's not good. Alright, so I hope you enjoyed this look and doing a quick, I wouldn't even call it a restore, I wouldn't even call it a repair, because really all I did was tinker around with it a little bit, and I got it to work with all the original parts as it came. Replaced a few tubes, and maybe it's working slightly better, but I still find it quite remarkable that it works. I don't think I've ever had a set work this well without having any work done to it. And lost hold again. Get back in there. Now I can't even get a lock anymore. Yeah, as these sets warm up, they kind of drift. Even so. Pretty impressive.